Welcome, and thank you for watching our first episode. It was reported in a systematic review published this month in International Immunopharmacology that asthma, a long-term lung disease, is significantly associated with reduced risk of dying from COVID-19. This sounds a bit counterintuitive, so let's look into it. You can use INTVL, the first mobile app truly dedicated to medical statistics, to recalculate the reported numbers as well as check some of the terms mentioned. Well-designed systematic reviews incorporating meta-analyses without problematic heterogeneity represent the highest level of evidence in scientific literature, that is 1A, and these have a central role in clinical guidelines. In a nutshell, if you're not familiar with systematic reviews, a meta-analysis is a statistical analysis of multiple studies, and heterogeneity represents the differences between the results that these studies report. At the moment, most meta-analyses involving COVID-19 studies do not have sufficient power, pooling results from 3 to 5 studies when most statisticians argue for at least 10. The article I first mentioned is a systematic review that incorporates a meta-analysis based on 56 studies. The authors concluded there was a statistically significant relationship between asthma and reduced risk of dying from COVID-19, based on the following results. They reported a pooled odds ratio of 0.82 with a 95% confidence interval of 0.74 to 0.91. They also reported heterogeneity statistics. The p-value for Cochrane's Q-test, which was reported as being below 0.01, as well as a tau squared value of 0.0494 and an I-squared value of 49%. The authors have done a fantastic job of systematically searching and analyzing this colossal amount of information, but have not emphasized how the heterogeneity present in their meta-analysis cancels the statistical significance of the pooled confidence interval, nor have they found the sources of heterogeneity following subgroup analysis and meta-regression. When I-squared is below 50%, does that mean the heterogeneity does not impact the results? Short answer, no. The I-squared statistic only tells us what percentage of the variance we observe is due to heterogeneity. It cannot tell us if the pooled results remain significant across different populations. In order to see how much the effect size varies across different populations due to heterogeneity, one must convert the pooled confidence intervals to prediction intervals. Prediction intervals have been strongly recommended by world-renowned statisticians and organizations for more than 10 years. Using INTVL, we can easily calculate the prediction interval. We input the effect size, the lower and upper bounds of the pooled confidence interval, the number of studies included, and the tau squared value. And there we go. The 95% prediction interval is 0.52 to 1.3. That means that asthma's relationship with COVID-19 mortality can vary greatly between populations, from having the risk to increasing it by 30%. Therefore, the effect does not follow the same direction across different populations, and more research is required in order to clarify the relationship between asthma and COVID-19 mortality. Thank you for watching. Like and subscribe if you found this episode useful, and download INTVL from App Store or Google Play.